طيب شباب. So last time يا شباب we started talking about the entropy balance for closed systems. Just a reminder, closed system is a system where the mass inside the system does not change with time. Okay, so, or in other words, the mass does not cross the boundary of the system. That's actually the right definition. Okay. And the way we introduce the entropy balance is that we said there is a entropy generation term within the system. Okay, so this sigma here is the entropy generation, okay, within the system. And we also said that entropy will transfer whenever there is heat transfer. Okay, so if there is heat transfer across the boundary from the surrounding to the system, or other ways, or the other way from the system to the surrounding, entropy also will transfer. Okay, so the total energy entropy change of the system is basically the net entropy transfer across the boundary plus the entropy generated within the system due to any irreversibilities. Maybe friction, maybe sudden expansion, etc. Okay, so this is basically the entropy balance, the way we introduce it. Any question about this equation, Shabab? Any question? Any question about this equation? Okay, so in a differential form, the equation can be written like this. Okay, ds is dq over t plus d sigma. And we said now if there is no internal irreversibilities in the system, this term sigma or d sigma will equal to 0. And then we end up with the basic definition for the entropy for internal reversible system, or for a system with internal with no internal irreversibility, or it is reversible, internally reversible system. Okay. واضح هذا يا شباب؟ Is this clear? Is this clear? سمعوني أصواتكم عشان أعرف إنكم معي.
ايه واضح.
Okay. Okay. The second thing we talked about here is that this integral, or the entropy transfer term, which is integral of dq over t, if it is positive, it will follow the same convention as the heat transfer, right? Since it is also dq over t. So when this term is positive, that means entropy will transfer into the system. And if you remember, we said Q is positive when there is heat transfer into the system. And if Q is negative, that means heat transfer out of the system. This is exactly the same. If dq over t, integral of dq over t is positive, then we will have entropy transfer into the system. If we have a dq over t is negative, then we'll have entropy transfer out of the system. Okay. And then we said the possible signs or values for sigma, which is the entropy generation term, is that it's either positive or 0. So يعني either you generate entropy within the system or you don't. Okay, if you don't, then sigma is 0. That means no irreversibilities in the system. If sigma is positive, that means there is irreversibilities present within the system. Okay, so this term, once it is generated, once we have positive sigma, you cannot remove this sigma, or you cannot reverse the sigma. Okay. And this is the important also of the one of the statements of the entropy statement of the second law of thermodynamics. Any questions so far? Any questions so far?
Yes, Doctor.
Yes.
You gave us an example before this one. We said that
yes.
assume it's freely moving piston. And by that, we assume that it's internally reversible process at a constant temperature and pressure. Does that mean
Yes, yes.
if it
You-
is internally reversible, the temperature and the pressure is constant always?
La, doesn't mean.
So does that information come with the question itself or what? Which is
Why أنا بسألك why was it temperature constant and pressure is constant? Why? If you remember the question.
I don't know. I don't remember.
Go back to the question. It was evaporation, صح? There is heat. It was starting from saturated liquid up
Yes.
to saturated vapor.
Yes, that's right.
And the piston was freely moving. Okay? And you know, during phase change, always go back to the original concept. Don't assume things or don't connect things that are not relevant. Go back to the original concept. We have phase change.
Yes.
The phase change, if there is freely moving piston, that means it happens at constant temperature and pressure. That's why it's constant temperature and pressure. It has nothing to do with.
Okay. Thank you.
Okay.
Yes.
So yeah, thank you for this question. Good question. Any other question? So the internally reversible, that means if you can bring back the system to its original state, let's say you take it from 1 to 2 and then from 2 to 1, then this is internally reversible. That's the basic concept. Okay? So it could happen at constant temperature pressure, it could happen at variant temperature pressure. It doesn't matter. As long as you can bring it back to the original state. That's an internally reversible system. Okay? So yeah, please focus always on the, it's important to understand the basic concept regarding that. Any other question? Good question. Any other question? By the way, Shabab, please do this online evaluation. Yani they send 100 emails per second. Please finish emails, okay? So that you can stop getting notifications. Okay, so let's continue. Let's go back to this equation, which is this one here, is to have another form. So we have the entropy balance, we said S2 minus S1. Remember, this is the extensive entropy, which is the capital S here, okay, equals integral from state 1 to 2 dq over t b plus sigma. Okay, remember b here, that means this integral is evaluated across what? If you have a system, this integral, since it's related to the heat transfer across the boundary, it's evaluated across or over the boundary, system boundary. Okay, so this is B. طيب. If the temperature of the boundary is constant, so one of the special cases يا شباب, if temperature of the boundary is constant, وش يصير? What is the result of this integral or the final equation? So you'll have S2 minus S1 equals, hi شباب, what do you think? So t will come outside, then you can just, integral of dq is just q over t of the boundary plus sigma. And this is the final form of the entropy balance. Entropy balance for a closed system with TB is constant, with constant temperature of the boundary. Okay. واضحة يا شباب? Is this clear? Is this okay? I have another form. I can write it also in rate form. If you remember the rate form, what is the rate form يا شباب? Who can remind me? لما نقول rate form يا شباب, what does this refer to?
Time.
In rate form it means per unit time. يعني this is not the total from time 0 to final time. This is per unit time. يعني per unit time. So basically it's like you're dividing by time. So basically in a rate form, so I can use this equation here for the rate form. So I'll just divide by dt. So I'll have the following. So I have ds by dt equals so I will write the integral as I will write it as a summation, because you might have different heat transfer at different points in the boundary. So for example, you have here 0.1, here 0.2, here 0.3, and each one has heat transfer per unit time and different temperature. So I can write it as Qi by Ti, okay, or Tj actually, all right, plus sigma dot. So this is just the rate form of the entropy balance, okay, but mainly we will be actually using this form. I think this is the form that we'll be using most of the time. Okay. Questions? So now we finished this entropy balance, so we have just examples. Just we have to solve some examples. Any questions before we solve examples? وضحت الentropy balance. I'm transferring entropy into the system. I'm generating entropy into the system. The summation of these two is just the total change of the entropy of the system. Okay. All right. Let's see here. Let's take an example. Okay. In this example, I will have again this piston cylinder. This piston cylinder here. I have water inside the cylinder. I have this system insulated. إيش يعني insulated؟ ها شباب إيش يعني insulated؟
No heat transfer into the system, or
So my Q is 0 لأنه I don't have heat transfer. Okay. The initial state of this water يا شباب, the initial state is saturated liquid. Okay. And the final state is saturated vapor. So basically I am evaporating this liquid from a saturated liquid to a final state of saturated vapor. How am I doing that, ya shabab? I have a fan that I have here, okay? And this fan steers this mixture, increasing its temperature or يعني خلينا نقول changing its phase from saturated liquid to saturated vapor, and the piston here is allowed to move. The piston is allowed to move freely, I guess, in this case. Okay, so it's doing that at a temperature of 150 degrees Celsius. Okay, 150 degrees Celsius. So the question is, the first question, find A, find the work done, specific work, I'll call it, specific work, and B, find the entropy generation per unit mass, per unit mass. Basically, here specific work is what? W over M. And the entropy generation per unit mass, what do I need? I want sigma over M.
Sigma over M.
Yalla Shah, how can I proceed with this problem? How can I proceed?
Work is equal integration BV EV.
طيب.
We have the initial state, it is saturated liquid, and the final state is saturated vapor. And the table we can get VG and VF and the pressure from the T.
طيب أنت تقول إنه for specific work اللي هو part A, I will use work equals integral of P dV كذا. كذا قصدك؟
أيوة.
طيب. So this is okay. So this is one way to do it. So you can do, it will be here integral of P d small v, and then, but the pressure, is it constant or not?
We don't have information of it.
We don't have the information for the pressure or the volume. So what's the other option?
The equation of the first law of thermodynamics.
Of what? First law of thermodynamics اللي هو ايش؟ Energy balance, صح?
Yeah,
So I have du equals Q minus W. صح؟ طيب, can I cancel here anything?
Q. Can cancel Q.
ليش? Q, not U.
Q.
Right? So my work here, this will be M delta U. So basically W over M is minus delta U, which is U2 minus U1. Okay? This is the first part. How can you get U1 and U2? Simply from the temperature and saturated, the F state and okay? Very straightforward. طيب, what about part B?
Sorry, doctor.
Yes.
The first method, you said we don't have enough information. Doesn't free piston means constant pressure?
I have a fan. I have a fan steering the liquid inside. So you are not sure exactly. It's not heat transfer that is causing the change, the phase change. If it is heat transfer, okay, I can tell you, okay, the pressure is constant. So you don't know. You can actually double check. And you can take this temperature, see what is the corresponding saturation pressure, right? And look at the phase change. Find the work using this method. So basically what you're gonna do is just what we wrote before. V2 minus V1. So you can try to take the saturated pressure at 150, okay, and V2 minus V1. V2 اللي هي ايش؟
VG
VG minus
VF.
VF. Okay. So you can try to do this one and see if you'll get the right answer. Actually, we can do it now. And if you help me with your tables, we can try it. But let me go to, yeah, actually, you know what? Before going to part B, let's do it. So from tables, then I want to the equation for the
Pressure
what is
for
pressure?
476.16.
Table A كم؟
A4.
ايوه كم
The pressure is 476.16.
the corresponding pressure is 400,
76.
okay, point
16. 16
kilopascal, right?
kilopascal.
طيب, what is VG?
VG is 0.2.
ايوه
0.3. 0.39. 24.
trusting
8.
you 0.39 ايوه 39 كم؟
48. 48.
3948 meter.
39248.
39248 meter per cube per kilogram will be F
0.00
ايوه
1091.
1091. طيب so احسب لي الديفرنس في ال V ضرب ال saturated pressure احسب لي على السريع.
يساوي 186.3.
186.3
36.
كيلو جول per kilogram المفروض. طيب this value is not like the right value that I have.
It's too off or it's close to the right?
Actually, so it's very off. That's the first thing. The second thing is the work here, ya shabab, is it done on the system or by the system? So this is this is a very good example to show you the importance of understanding the concept very well. What is the work? Is it done on the system or by the system?
The work is done on the system.
It's on the system, صح? لأنه I'm using a fan and applying work on the system, right? But this value give me what? The work done by the system on the piston. And that's not what I want. I want the work done on the system to change the phase of the system. Okay, that's why we cannot use this one PDV. عرفتم الفرق؟ So when you have external source factors affecting the system, applying work on the system, you cannot use because this is not solely expansion or compression work يا شباب. يعني this is not 100% compression or expansion. يعني there is not only a system with doing work on a piston. No. There is also something else additional doing work on the system. Okay? this value كأنها تعطيك الفراكشن كأنك تقول لي إنه ما في إيش؟ ما في فان. Which is wrong. عرفت الفكرة؟ And the reason for this is that the pressure here is not the right pressure, so the pressure inside will change. Yeah, what I believe is happening. So, because of that, I cannot use this equation. So this is a wrong way to do it, and this is not the right way to do this. فهمتوا الفرق يا شباب لما نتكلم if you have expansion or compression work, this is if you have 100% expansion or compression without any other factors, you are right. لكن I have a fan happening here, so I cannot use PDV. I have to use the energy balance.
It is way off.
Or
Just
the
shake it.
yes. Okay. وضحت يا شباب ولا برضه في confusion؟ وضح ليش we cannot use PDV؟ لأنه الفان هذه يا شباب، الفان هذه is doing work on the system and on the piston. يعني الفاينل work اللي بيطلع لي the right work will also include the work happening on the system. يعني كأنه net work. The network will consider the work done on the piston and the one on the system by the. وضحت الفكرة؟ And how do you find that work? Using this equation W over M equal minus delta U. That's the right way to do it. Any questions? هذه كانت very good point. And we wanted to elaborate. طب how do you find the general entropy generated? What do we do?
From the table, we said.
لا الحين خلنا نسوي بس equation.
The entropy.
So for the second part, entropy generation per unit mass, how do you find it? Which equation should we apply?
S1 S2 minus S1.
اللي هو دلتا اس اللي هو entropy balance. يعني هذا entropy balance. So
from the table too also.
So delta S. So for this case يا شباب, so the temperature everywhere is 150. So I will consider it also the boundary is constant temperature. So I have Q of plus sigma. طبعا since our Q is what? What is Q? Across the boundary.
0.
So we have a system boundary. So Q is 0. So basically sigma over M equals delta S. As simple as that. اللي هي S2 minus S1.
اللي هو 4.9953.
بالضبط 4.99 بيطلع الجواب اللي هو SFG يعني.
ايوه محطوط على طول.
So this one will be what يا شباب؟ اللي هو this is minus UFG at 1 and this is SFG at 1. Okay, so W over M, I'll give you the final answer as I have it here, minus 192782 kilojoule per kilogram, and sigma over M equals 4.9961 kilojoule per kilogram. This is for just to clarify. أي سؤال هنا؟ Any question? واضح يا شباب؟
واضح.
ايوه.
طيب let's take quickly another example. It's gonna be similar, something similar. So example 2. In this example يا شباب the same thing. I have a piston. بس خلنا عشان قال لك إن غيرنا السؤال خليه من الجنب كده. Okay. So we have a piston cylinder like this. So it consists of not water this time. This is refrigerant 134. Okay. And I'm actually compressing this refrigerant similar to before يا شباب. I have insulated, the system is insulated, and I'm doing what? I'm doing adiabatic compression. So I have adiabatic compression. That means I'm compressing with no heat transfer with no heat transfer. What are the different states? What's the initial and the final? So the initial state is I'm starting this refrigerant at saturated vapor, saturated vapor at 0 degrees Celsius. Okay, and the final is a pressure of, because I'm compressing, the pressure actually should increase, and a final state I have a pressure of megapascals. Okay, the question is find, so تخيلوا معي انه I'm starting to apply, so I'm increasing force, I'm increasing until I start the compression. And the question I want, what is the minimum work required to perform this process? Give me a second يا شباب بس معلش. Yeah, so the question is يا شباب is to determine the minimum theoretical work input required. Okay, so we need the minimum theoretical work required to compress the refrigerant from the first state or the initial state to the final state. Is the question clear? يعني أنا عندي I want to perform adiabatic compression. Okay, I can do, يعني I can have, for example, I can do work يا شباب with, for example, and to clarify, I can do work where I have some irreversibilities. Maybe I have friction, maybe I have other sources of irreversibility, right? Which will require what? More work. معي يا شباب? Are you following me? يعني I can apply work to this system where you have some irreversibilities inside, which will require me higher work or higher work input. What is the minimum work or theoretical work required based on this understanding اللي هو ايش؟
دلتا اس.
اللي هو it should be for internally reversible process اللي هو we will assume there is no friction, there is no internal irreversibility, which is considered the minimum theoretical work. Okay, that means what is the entropy in this case?
Q over G.
شباب
القانون اللي استخدمناه بداية أول واحد اللي هو work is equal B dV.
Zero entropy.
Zero.
or okay. The change of entropy should be what?
Zero.
Zero.
Should be zero. يعني if I want the minimum theoretical work, that means I will say I will not generate any entropy. So the entropy generated should be what?
Zero.
صح ولا لا؟ Let's go back again. Let's go back again. So I have this system. It will require some certain work to go from this initial state to this final state. هذه واضحة؟
أيوة.
أيوة.
Is this clear? So I need to apply work to go from this state to the final state. إيش المشكلة؟ إنه I don't know the properties. يعني let me يعني here, for example, if let's apply for the sake of this, let's apply the first law. Okay, let's apply the first law in order to find the work. أنا قلت لك إنه this is insulated system is very similar to the previous problem. So what is the procedure? So I have du delta u equals q minus w. ممتاز. طيب ال q here is 0. So w is what?
Minus delta U.
U1 minus U2.
So basically, exactly. So it's similar to before, u2 minus u1 minus delta u. ممتاز. طيب السؤال what is u1 what is u2? u1 I can find it from the g state at 0 degrees. So this is okay. معي? Is this okay?
Yes.
Yes.
شباب. Okay. The question is what is u2? U2 is a property, so I need at least two independent properties to find U2.
Should be compressed liquid, right?
I don't know. I have only one pressure.
Yes.
I have only one pressure. I have one pressure. I need the second property. صح ولا لا؟
Right.
I need a second property. عشان كذا أنا ما قلت لك find the work. قلت لك find the minimum theoretical work. What does this give you? This gives you information for the second property. Which is second property?
Entropy.
ليش؟
Entropy is equal to 0. Delta entropy.
Delta to 0, that means let's write the entropy balance يا شباب to clarify. So I have S2 minus S1 equal, right? dq over T plus sigma, صح? Let's write it over M here. And this is, I can write over M, okay? So this dq is 0 لأنه it's insulated, right? So the question here is S2 minus S1 equals sigma over m. وش البوسيبل فاليوز يا شباب for this sigma؟ احنا ايش قلنا؟
0 or positive. 0.
0 or positive. What is the minimum theoretical work?
0.
What is the minimum value here for delta S? Is 0. For يعني
So
for
S1 is equal to S2.
بالضبط for minimum work S2 minus S1 equals to 0. That means S2 equals to S1. In this case يا شباب, I have what? I can find S1 from the first state, which is gonna be the same as S2. So I have S2 and I have P2. خلاص, now I can find U2. Got it? Is this clear?
Yes, doctor.
يعني to clarify even more, exactly what I told you just a few minutes ago, a minimum theoretical work refers to the work you can apply without irreversibilities. The maximum theoretical work فصل مرحبا شباب, تسمعوني؟
ايه وتسمع.
ايه صح كده.
فصل فجأة شوي, عندي النتورك هنا اليوم ما ادري ايش فيه. تشوفون الشاشة؟
ايه نشوف الشاشة.
كلير؟
إيه.
اوكي. كنت اقول انه if you remember the cycle يا شباب, when we said the maximum theoretical cycle كانت for reversible cycle, صح? There is no irreversibility in the system. This is exactly the same thing. Here the minimum theoretical work is the minimum I can apply without irreversibilities. لأنه reversibilities will put more resistance to apply more work. And this comes because of the entropy. So the entropy here, the entropy balance tells you, if I'm not generating here for irreversibilities, do I generate entropy?
No.
For internally reversible, I don't generate any entropy, so I will consider it equals to 0. Okay? So the minimum theoretical work is when you have no entropy generation. هذه احفظوها كده, فهموها. Okay? Minimum theoretical work if you don't have any internal generation of entropy. And you don't have generation of entropy. That's why here this becomes 0 and then S1 becomes equals to S2. Then I can go and calculate U2. Okay? So at state 2, I have P2 and S2. And from these, you can find U2. Okay? So I'll just give you final answer for this, and you can work it out yourself. So the final answer, I will give you U2 at minimum work, which is at minimum, okay, equals 244.32 kilojoule per kilogram, and then work per mass minimum equals minus 17.26 kilojoule per kilograms. Okay, so this is the minimum theoretical work you can apply on the system. If you have internal irreversibilities, this becomes higher, so S2 becomes higher than S1, and then you will have some generation. أي سؤال يا شباب؟ أي سؤال؟ Any question? So inshallah next class we'll take maybe one more example and then move to the entropy rate balance for control volumes. So we'll be done with the closed system, we'll move to the control volume, and then move to the isentropic processes, which are processes with constant entropy, okay? And then what we call the isentropic efficiencies of the turbines, nozzles, compressors, and pumps. And this should conclude chapter 6 بإذن الله تعالى. يعني إذا شديتم حيلكم معي يا شباب, we'll try to finish as early as possible. So I'd like to give you a quiz on Blackboard, يعني بيكون على البلاكبورد. Maybe Tuesday is okay. على chapter 5 بيكون.
Thursday دكتور. سبيسال.
ترى we're late.
يوم
يعني
الخميس أفضل.
خميس.
إيه.
طيب خلونا نشوف. طيب خلاص خير إن شاء الله. يعني حتى ودنا نخلص بدري, والمشكلة برضه لازم أبغى أعطيكم كويزات, وحتى في كلاس تيست. لو خلينا الكلاس تيست برا الكلاس تايم, is it okay؟
ايوه ما
Yes.
عندي مشكلة دكتور.
ما في مشكلة.
اوكي
Okay, no problem.
طيب اوكي. افكر خلاص الخميس يكون مثلا كويز على شابتر 5, وممكن الاسبوع اللي بعده يعني الاحد او الثلاث او الاثنين, اذا انه ما عندكم مشكله مثلا خارج الوقت الكلاس, اعطيكم الكلاس تيست. تمام.
نعم دكتور يعطيك العافية.
يلا بالتوفيق يا شباب. I will update you with an email باذن الله. يلا سلام عليكم.